Aluminium air batteries or Al-air batteries produce electricity from the reaction of oxygen in the air with aluminium. They have one of the highest energy densities of all batteries, but they are not widely used because of problems with high anode cost and byproduct removal when using traditional electrolytes, and this has restricted their use to mainly military applications. However, an electric vehicle with aluminium batteries has the potential for up to 8 times the range of a lithium-ion battery with a significantly lower total weight. Aluminium air batteries are primary cells, i.e., non-rechargeable. Once the aluminium anode is consumed by its reaction with atmospheric oxygen at a cathode immersed in a water-based electrolyte to form hydrated aluminium oxide, the battery will no longer produce electricity. However, it is possible to mechanically recharge the battery with new aluminium anodes made from recycling the hydrated aluminium oxide. Such recycling would be essential if aluminium air batteries are to be widely adopted. Aluminium-powered vehicles have been under discussion for some decades. Hybridization mitigates the cost, and in 1989 road tests of a hybridized aluminium air-lead-acid battery in an electric vehicle were reported. An aluminium-powered plug-in hybrid minivan was demonstrated in Ontario in 1990. In March 2013, Fenergy released a video demonstration of an electric car using aluminium air cells driven 330 kilometers using a special cathode and potassium hydroxide. On May 27, 2013, the Israeli Channel 10 evening news broadcast showed a car with Fenergy battery in the back, being fueled with pure, drinkable water, claiming 2,000 kilometers range before replacement of the aluminum anodes is necessary. Electrochemistry. The anode oxidation half reaction is Al plus 3OH minus Al3 plus 3E minus 2.31 V. The cathode reduction half reaction is O2 plus 2H2O plus 4E minus 4OH minus plus 0.40 V. The total reaction is 4Al plus 3O2 plus 6H2O 4Al3 plus 2.71 V. About 1.2 volts potential difference is created by these reactions, and is achievable in practice when potassium hydroxide is used as the electrolyte. Saltwater electrolyte achieves approximately 0.7 volts per cell. Commercialization. Use aluminium as a fuel for vehicles has been studied by Yang and Nickel. They concluded the Al-air battery system can generate enough energy and power for driving ranges and acceleration similar to gasoline-powered cars. The cost of aluminium as an anode can be as low as $1.10 per kilogram as long as the reaction product is recycled. The total fuel efficiency during the cycle process in Al-air electric vehicles can be 15% or 20. Comparable to that of internal combustion engine vehicles. The design battery energy density is 1,300 watt-hours per kilogram or 2,000 watt-hours per kilogram. The cost of battery system chosen to evaluate is $30 per kW or $29 per kW. Al-air EV's life cycle analysis was conducted and compared to lead, acid and nickel metal hydride EVs. Only the Al-air EVs can be projected to have a travel range comparable to ICE's. From this analysis, Al-air EVs are the most promising candidates compared to ICE's in terms of travel range, purchase price, fuel cost, and life cycle cost. Technical problems remain to be solved to make Al-air batteries suitable for electric vehicles. Anodes made of pure aluminium are corroded by the electrolyte, so the aluminium is usually alloyed with tin or other elements. The hydrated alumina that is created by the cell reaction forms a gel-like substance at the anode and reduces the electricity output. This is an issue being addressed in the development work on Al-air cells. For example, additives that form the alumina as a powder rather than a gel have been developed. Modern air cathodes consist of a reactive layer of carbon with a nickel grid current collector, a catalyst, and a porous hydrophobic PTFE film that prevents electrolyte leakage. The oxygen in the air passes through the PTFE, then reacts with the water to create hydroxide ions. These cathodes work well, but they can be expensive. Traditional Al batteries had a limited shelf life because the aluminium reacted with the electrolyte and produced hydrogen when the battery was not in use, although this is no longer the case with modern designs. The problem can be avoided by storing the electrolyte in a tank outside the battery and transferring it to the battery when it is required for use. These batteries can be used, for example, as reserve batteries in telephone exchanges and as backup power sources. Al batteries could be used to power laptop computers and cell phones and are being developed for such use. Aluminium-based batteries. Different types of aluminium batteries have been investigated. Aluminium chlorine battery was patented by United States Air Force in the 1970s and designed mostly for military applications. They use aluminium anodes and chlorine on graphite substrate cathodes. Required elevated temperatures to be operational. Aluminium-sulfur battery worked on by American researchers with great claims, although it seems that they are still far from mass production. It is unknown as to whether they are rechargeable. Alpha-O, LCUO and Alpha-O batteries were proposed by some researchers for military hybrid vehicles. Corresponding practical energy densities claimed of 455, 440, and 380 watt-hours per kilogram. Lmno manganese dioxide battery using acidic electrolyte produces a high voltage of 1.9 volts. Another variation uses a base as the analyte and sulfuric acid as the catholyte, the two parts being separated by a slightly permeable film to avoid mixing of the electrolyte in both half cells. This configuration gives a high voltage of 2.6–2.85 volts. Al-glass system, as reported in an Italian patent by Biocchi. In the interface between common silica glass and aluminium foil at a temperature near the melting point of the metal, an electric voltage is generated with an electric current passing through when the system is closed onto a resistive load. The phenomenon was first observed by Biocchi, and after Dell'Era et al. began the study and the characterization of this electrochemical system.